Alright, in this section we go over inverse trigonometric functions. Well, so in this section we cover to find the exact values of an inverse sine, cosine, and tangent function. Use properties of function to find certain values that involve composite functions with trigonometric functions and their inverses. And then we are going to find the inverse of a trigonometric function and solve equations that involve trigonometric functions. Well, just to recap, well, in the previous chapter, essentially we learned how to find sine of pi over 4. Well, in this case, it was square root of 2 over 2, right? Now in this case, we're going to look for the question. So sine inverse of the value square root of 2 over 2. In other words, which angle theta has a sine equal to square root of 2 over 2? Just like here, well, sine of the angle equals the value. Now we're given the value, they're asking us for the question. Well, in this case, pi over 4. But of course, we're going to have a lot of restrictions, a lot of very, very important details to keep in mind when it comes to uh, dealing with this kind of function. So it's not just that easy to do the inverse. Well, we will have some restrictions. You will see why. Alright, so let's look at the inverse sine function. Well, let's recall that if a function is 1 to 1, then it will have an inverse. Well, the question is the sine function a 1 to 1 function? Well, let's figure that out. Well, number one, there's a test that we do to determine whether the function, a given function, or the graph of a function represents that of a 1 to 1 function, and in this case is the horizontal line. And unfortunately, look at this, it crosses more than once, so that's why this function, as it is, sine of x, is not a 1 to 1 function. Now, if you look at the picture, well, we can make this function be a 1 to 1 function under some restrictions. You might remember from the inverse functions chapter when we had y equals x squared. Well, that's a parabola. All right, if we draw this parabola, very simple parabola, in this case, well, horizontal line test, it fails. All right. However, if we say on the other hand y equals x squared with the condition that x is only positive and 0, well, in that case the function passes the horizontal line test, and therefore we are going to have a 1 to 1. So in this case, not 1 to 1, in this case 1 to 1. All right, so we're going to take this same idea when it comes to defining the inverse trigonometric function. So in this case, we are just going to grab a simple, just one sector of the function that doesn't cross the graph at more than one point. And in this case, the part of the graph that goes from negative pi over 2 to pi over 2. Right? And actually, it's right here. Now, if we do the horizontal line test for this graph, well, now it passes the horizontal line test, and therefore it's 1 to 1. Right? Not 1 to 1, 1 to 1. What are the properties of this function? Well, let's have a look. So number one, the inverse sine function has the following symbol. It has this to the negative 1 notation. Be careful, that's not reciprocal, that's not an exponent either. This is to tell that this function is its inverse. There's another notation for this kind of function. The other notation is using the arc notation, arc sine of x. All right, arc sine, that's another way to denote this. Either way, all right. And well, I mean, by inverse functions definition, y equals inverse sine of x means x equals to sine y, where in this case the domain of the inverse function is reversed with the range of the original function. That's what happens um, when we invert a function. So domain, range. And you can in this graph right here, you can see, well, the one in pink right here is a sine function only over the period, well, not a period actually, it's just over the range where it's 1 to 1, and its inverse is this one right here, in which the range the domain goes from -1 to 1, and the range goes from -pi/2 to pi/2. Likewise, if you look at the original sine function, domain and range are reversed. All right. So let's look at some examples on how to deal with the inverse sine function. Well, so let's find the exact value of the following. All right. So in this case, they are asking us to find the angle for which sine equals to square root of 3/2. Well, in this case, of course, you might want to rely on the unit circle. That's the unit circle is coming back. I'm gonna have it here. That's gonna be very, very useful in this section. Now be careful when evaluating inverse sine, because inverse sine, it's only it only takes values between -pi/2 and pi/2. So we're going to look for the value where sine, that is the y coordinate, equals to square root of 2/2. All right, that is cosine and sine. And in this case, well, we found out that sine equals square root of 3/2 for the angle pi/3 or 60 degrees. So simply pi/3. Final answer. Inverse sine of -1. So what angle it has a sine of equal to 1? Well, in this case, well, again, this is cosine, this is sine, and again the range of the inverse sine function goes from -pi/2 to pi/2. And in this case, well, this is the angle where sine equals to 1. In other words, pi/2 or 90 degrees. So pi/2. For which angle theta is sine equals to 1/2? Well, sine equal to 1/2, we have it here. Pi/6 or 30 degrees. All right, now let's look at other values such as sine theta equals, inverse sine of 1/3 and inverse sine of -5/4. All right, in this case, since these are not values that are in the unit circle, we're going to use a calculator. But make sure that that your calculator is set to be in radians. Well, let me just verify that real quick. Let me check that on my notes before moving on to. Okay. Not this page. Yes, it has to be in radians, of course. All right. Of course, we can incidentally use it depending on the application on our purpose. But well, most likely MyMathLab, when you do the homework, it's gonna ask you to have your calculator in radians. So we have it there in radians. So let's just go ahead and do that. So in this case, we have keys for Inverse sine, it's in blue. That means we need to hit second sine. That's going to give us inverse sine of 1/3. Click enter, and well, we typically round this to 2 decimal places. Well, 0.339, that's 0.34. All right, so where's my blue marker? Here it is. 0.34. All right, let's evaluate sine, the value of sine, the angle whose sine is -5/4, and in this case, unfortunately, this is undefined. All right, so this is undefined because because sine only goes from -1 to 1. Let's verify that using the graphing calculator. -5/4, and yeah, so you would get an error here if you try to evaluate this one. It's not in the domain. All right, so okay, what about properties of inverse functions to find exact values of certain composition functions that in this case involve sines and its inverse, which is arcsine or inverse sine? Well, just to make an analogy of what we did in the logarithms and exponential functions. Well, when we had ln of e to the x, this equals boom boom, they cancel out and gives us x. And in this case, for all x in the real numbers, because the domain of the exponential function is all real numbers. However, in this case, in the other hand, when we do e to the ln of x, well, this cancels. Well, in that we use these two properties to solve equations and do some composition functions. In this case, it's also x, but in this case, we need to be very careful with the value of x that we put. In this case, we need to make sure that x is greater than 0. Otherwise, well, we would be in trouble if we put a negative number. All right, or 0, because ln of 0, it's a negative infinity. Well, it's a number that we can't really use at this moment. All right, so now let's see. So going back to this, ln of e canceling to get x and e canceling the ln. Well, similarly, we have this inverse sine cancel the sine to get x, but we cannot just do that. We need to make sure that the input is right here. The input is between -π/2 and π/2. All right, so in this case, let me highlight that part. All right, we need to make sure, we need to have that connection here. We cannot just cancel, cross cancel if the value of x is not within these two bounds. All right, what about the composition in the other order? Well, let's see. So let me use a different color here. Well, when we do the composition the other way around, well, we need to make sure that x is between -1 and 1. All right, so again, in the logarithm and exponential function, the first form, well, it's okay for all real numbers. The second way is only okay for positive numbers. And in this case, well, we have other restrictions in a very similar mindset here. So let's go ahead and do some examples and how we treat this when we don't have something that is within these ranges. All right. Okay, let's find the exact value of each of the following composite functions. Well, number one, pi/8. Where is pi/8? So pi/8 is halfway through between 0 and pi/4. So I'm gonna say pi/8 is over here. All right. Now notice in this case, I shaded the OK regions in which we can just do boom boom, cancel inverse sine with sine. So in this case, final answer pi over 8. Okay, and that's because the input that we have lies within the green region that goes from negative pi over 2 all the way to pi over 2. All right, which is what the restriction that we have here. All right, let's see. Can we just do boom boom here? Well, be careful. Let's see. So 5 pi over 8. 5 pi over 8, well, that's a 0. Pi over 2, or which is the same as 4 pi over 8. And 5 pi over 8 is somewhere here. We're in trouble here. We're in trouble big time. So why is this? Well, first of all, let me label this as 5 pi over 8. All right. So in this case, we need to move this angle here. We need to move this angle here in two potential positions. Number one, we can project it here. All right, that's one potential solution. The other potential solution is to move it all the way here. If we move that here, well, this would be, well, that'll be 3 pi over 8. All right. However, if we move it towards this direction, we are going to have negative 3 pi over 8. So those are the two potential solutions to choose from. Which one are we going to take and why? Well, number one, you might want to recall the fact that here in this case, let me use a different color here that actually does a good contrast. Well, I guess this is going to be a good color. All, no, that's not going to look fine. I need a better color here. Well, orange. Hopefully that works. The A stands for all. The S stands for sine. The T stands for tangent, and the C for cosine. That means that in this quadrant, all functions are positive. Over here, sine is positive. Over here, only it's sine and its reciprocal cosecant. Over here, tangent and its inverse and its reciprocal cotangent. And here, cosine and its reciprocal secant. Well, number one, we're talking about 5 pi over 8. And in this case, well, we are in a position where sine is positive. All right? Sine is positive. So we need to move this angle to any of these two. So in this case, what is the other position in which sine is also positive? Well, in this case, here cosine is negative. This is not going to be a good choice because here sine is negative. However, this is going to be the good choice because here we have sine to be positive. So we need to move it where sine is also positive. So first of all, we need to rewrite this as a sine inverse of sine of 3 pi over 8. Only then we are good to go and do boom boom. Cancel out sine inverse with sine. Final answer 3 pi over 8. Alright, it was a little, I understand it might have been a little bit tricky to go about this calculation, but it's about we are in a situation in which the angle is outside of the okay range for the function, and we need to move it to either one of these in a way that it can be simplified. Alright, let's do another example. Well, 7 pi over 6. So 7 pi over 6, that's a little bit more than, so pi is the same as 6 pi over 6. Over here, well, we are going to have 7 pi over 6. Alright, again, we have an angle that is outside of the okay range for sine. Alright, or sine inverse rather. So we have two options here. Number one, do we project this over here? And in that case, it would be pi over 6, alright, because this representative angle or related angle is pi over 6, so this is also pi over 6. Or the other option is to move it here, where this is negative pi over 6. Alright, what is going to depend? Well, in this case, since we are trying to evaluate a sine function, in this case, let me do again the A, S, T, C. So in this case, in this third quadrant, only the tangent function is the only one that is positive. Sine and cosine are both negative. Alright, so now I need to move this angle, potentially this one, as long as sine is a negative, it's a negative value. Well, in this case, here all trig functions are positive, so that's not going to be useful because I want sine to be negative, so it has to be this one. So what we need to do here is rewrite this as sine inverse of sine of negative pi over 6. And only then we can just do boom boom and eliminate the sign with negative pi over 6 is the final answer here. Alright, so in this case, do you see the difference between these two examples? Well, in this case, we had an angle whose sine is positive. We needed to move it to a region in which sine is also positive, not negative. In this case, we had an angle in which the sine function is negative. We needed to move it this time to another place within the green region in which sine is positive, because here only cosine is positive. Alright, let's look at compositions in the other way around. Notice in the first three examples we did sine inverse of sine, sine inverse of sine, sine inverse of sine. In the last couple of examples, we're going to do the compositions the other way around. So sine of sine inverse, sine of sine inverse. So let's see if we can just do this. Well, let's go back to the definition here. So yes, we can do this cancellation as long as x, the input, lies between negative 1 and 1. Alright, well, in this case, the number 0.4, well, we can just cancel this out because 0.4 is a number between negative 1 and 1. Over here, well, in this case, sine inverse of 1.6, well, in this case, if you just consider the inner shell of the function, well, what's the inverse sine of 1.6? Well, in this case, we just say that it's undefined. Because the first operation, the innermost operation, is not going to go. And that's because the range of sine. So we're looking for the angle whose sine is 1.6. Well, keep in mind that sine ranges between negative 1 and 1. So this is outside. Alright? So this is simply undefined. This is not a go. Alright, let's look at next page. The next topic. We are going to do essentially the same, but with inverse cosine function. Alright, so let's see. Same question. Is cosine a one-to-one function? Well, horizontal line test. Do you see it crosses more than once? So we are going to take only the portion of the cosine function in which passes the horizontal line test, and therefore it is a one-to-one. And the properties very similarly, well, it's symbolized as a cosine to the -1 or cosine inverse of x, or arc cosine of x. All right, that's another way to denote this function. And the same, y equals cosine the -1 of x, or y inverse cosine of x is the same as saying x equals cosine y. And well, the domain and range, well, they're gonna be very similar. Well, -1 to 1 for x, but for the y values, it's not gonna go from -pi/2 to pi/2 in this case. If you look at the graph, it's gonna go from 0 to pi. And here you can see the two graphs together and having the diagonal line actually cutting these two into exact mirror images. Alright, let's find inverse functions related to the cosine function. Well, so for which angle is cosine equal to 0? Well, in this case it goes from 0 to pi. I'm going to look for angles between this region. Alright, so the function whose cosine is 0 is no other than pi/2 or 90 degrees. The angle whose cosine is -√2/2. Well, let's find out what that is. So I'm looking for √2/2. Well, in this case these two are positive, so it's not going to be useful. I need to keep moving around, making sure I don't get past the pi limit. So I see the -√2, and it's actually the x-coordinate, cosine, sine. And what's the related angle? 3 pi/4 or 135 degrees. All right. So 3 pi/4. What's the angle whose cosine is positive? 1/2. Okay, let's go back to the unit circle. I'm going to look for an angle here within this region where the x-coordinate is 1/2, and that's pi/3. All right. And same, of course, we're going to have values that are not in the unit circle. Well, or at least in this common unit circle. So we cosine inverse, we're gonna have to do this again. Second inverse cosine of 1/4, and that's 1.318. We round to 2 decimal places, 1.32. All right, the inverse cosine of -7/6. Well, that's gonna be, of course, undefined. Because the range of cosine goes from -1 to 1, and this number is outside of that range. So let's just verify that. That's second cosine of negative, is that 7/6? -7/6. Yes, of course. All right, as expected. Same properties. All right, same. Now let's evaluate composite functions involving cosine and inverse cosine. And just like we did in the previous examples, in the previous part of this, the first part, or actually the second part of this section, we're going to evaluate cosine inverse of cos. But in this case, it's not going to go from -pi/2 to pi/2. It's going to go from 0 to pi. And in this case, for the pictures I drew for you, well, I have shaded that 0 to pi, 0 to pi, and 0 to pi. All right, and likewise for the reverse order of the composition, we need to make sure that x lies within -1 and 1. All right. So let's just go ahead and do a couple of examples. Well, cosine inverse of cosine of pi/12. Well, pi/12 is halfway through pi/6. I'm gonna just estimate it over here. And in this case, this one is really nice because it's within within the green region, the shaded region. So in this case, we are just clear to simply cancel out this cosine inverse with cosine. That's simply pi over 12. Can we do this again? Well, let's find out. Well, look at this. We have a negative angle. It's not going to work. This is what we're going to have. We're going to have negative 2 pi over 3, but negative 2 pi over 3, so this is 2 pi over 3 somewhere here, and 2 pi over 3 over here. So it's going to go somewhere here. All right? And if we look at the angle, it's outside of this green region, so negative 2 pi over 3. So we have two options. Number one, do we move this angle over here, or do we move this angle over here? Now, this angle right here is in the third quadrant, where the cosine function is negative. All right, we need to move it to either one of these two quadrants so that cosine is also negative. We cannot just move it to anywhere that we want. So in this case, well, keep in mind that here all the trig functions are positive. So, well, the projection would have been, in this case, pi over 3 and 2 pi over 3. All right. So in this case, in this quadrant, only sine is positive, but cosine is negative, so this is the good choice, not this one. All right, so what are we going to do? First, we need to rewrite this as cosine inverse. Instead of negative 2 pi over 3, write it as 2 pi over 3. And in this case, we're good to go and simply cancel this out, and this is 2 pi over 3. Now, maybe there wasn't any need to do all this diagram, because if you look at this, the cosine function is an even function and the negative sign disappears. That's another way to understand this problem, to go about this problem. All right, I mean, it's valid. And then when you look at 2 pi over 3, it turns out it's within the green region. However, it's good to practice the way we do this, because we're gonna need this a lot when we do these kind of problems. All right, so now in this case, can we just cancel cosine inverse cosine? Well, let's find out. 11 pi over 6 is just pi over 6 away to 2 pi, somewhere here. I'm just going to estimate it over here. I need this. It's not supposed to be a pi yet. So 11 pi over 6. All right. So on the one hand, we can project this to over here, or to give us this angle, or we can project this over here to give us that angle. On the one hand, well, this is pi over 6. That's one potential solution, or the other solution is to have a, well, this is also pi over 6. That's pi over 6 away from pi. That's 5 pi over 6. Well, in this case, we're in the fourth quadrant, where this time, as opposed to the previous example in which cosine was negative, in this case, cosine is positive. So if I translate this angle to over here, yes, I mean it's a good reflection. However, in this case, cosine is negative in this second quadrant. So in this case, it's not going to be an okay solution. So the actual one will be pi over 6. So now we need to rewrite this as cosine inverse of cosine of pi over 6. Only then we're good to go and cancel this out. That's going to be pi over 6. Final answer. And for the remaining, using calculator, just like we did for sine, be sure for the reverse order, be sure that x is within -1 and 1. All right. So in this case, we can do this because 0.4 is between -1 and 1. In this case, undefined, because 2.3 is outside of the range -1 to 1. Also, this one is undefined. Be careful with the symbol. This pi might look like, oh, it's within the green region. Alright, but look at the order of the composition. This is cosine of cosine inverse, not cosine inverse of cosine. Alright, so this is also undefined because pi is 3.14, blah blah blah. You know the drill for this. And this number is naturally outside of the range -1 to 1. Let's repeat all this for the tangent function, for the inverse tangent function. And the same question, is the tangent function a one-to-one function? Well, let's find out. Nope, 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 and no. See how many times does the graph crosses, the horizontal line crosses the actual graph, so that's why it's not a one-to-one function and therefore not invertible in the first place. However, if we just take a portion between -pi/2 and pi/2, surprise, surprise, well, it is now an invertible function. It's a one-to-one function. So we are able to do this again with inverse tangent function. And of course, the usual, this is also denoted as arctan. Arctan of x, and so in this case y equals tangent inverse of x means x equals tan of y, but in this case the domain of the function is all real numbers and the range just goes from -pi/2 to pi/2. You know, the asymptotes, all that gets inverted. Okay, let's now find the exact value of the following. Alright, so now we're looking for the angle whose tangent equals to 1, and in this case this is pi/4. Because if we go to pi/4, the tangent function, which is y/x, square root of 2/2 divided by itself, it's going to give me 1. So that's pi/4. The angle whose tangent is -√3. Well, in this case, we need to be, again, we're going to go within the range -pi/2 to pi/2. That is, we're going to go from here to over there. So in this case, I need -pi/3, and this might be a little bit tricky to do. Well, this is y, this is x, so now that's not going to be the 1, it's actually -√3/2 over 1/2. When we divide these numbers, let me write this down. Actually, it would be a good idea to rewrite this tangent inverse of, in this case, √3/2 over, well, actually negative and 1/2. I know it's kind of a little bit weird to rewrite this simple number because ultimately these twos cancel and √3/1 is √3 and then the negative angle. And in this case it happens to be, well, be careful because we have 5pi/3, but 5pi/3 is not within the range of the function. So instead of 5pi/3, this is actually, instead of 5pi/3, this is negative. This is the same as saying negative pi over 3 because we're going in the negative direction. So the answer to this will be negative pi over 3. Composition properties. Well, inverse tan of tan it has to lie between negative pi over 2 and pi over 2, just like the sine function. And the one that is the most liberal for this one, we can do tangent of inverse tan and simply cancel this out because these are, we can plug in any number because that's a negative infinity to positive infinity. Actually, this should have been just not equal, exclusive. Alright, find the exact value of the following composite functions. Well, pi over 3. Pi over 3 is over here. Well, that's good. That's really nice because it's within the range of its function. So in this case, we can simply cancel this out. This is pi over 3. Can we say the exact same thing about these two examples? Can we just boom boom? Well, let's find out. 3 pi over 5. 3 pi over 5. Well, that's a little bit over pi over 2. Well, because 3/5, 3 over 5, that's a little bit than 0.5, all right? Which is pi over 2. So I'm going to estimate this to over here. So 3 pi over 5. And of course, it's outside of the range. So either we translate the angle to over here to like, let's see what kind of angle this would be. We'll find out. Or we can do it over here, in which, of course, this is negative. If this is 3, this is 2 pi over 5, negative 2 pi over 5, and positive 2 pi over 5. Now, in this case, tangent is negative. All right? We need to move this angle in the portion of the region in which it's all tangent, it's also negative. Keep in mind that here it's all functions are positive, so we disregard this potential solution. In this case, tangent is positive over here, so this is going to be our good solution. So write this down as tangent negative to the negative 1, or actually the inverse tangent of tangent of negative 2 pi over 5. And this will be, only then we can do this, and that's negative 2 pi over 5. Final answer. Let me make this look like a 5. Yes. Negative 5 pi over 6. So that's just some portion of, that's just 1 pi over 6 away from negative pi. Well, in this case, we go clockwise to 5 pi over 6, or negative 5 pi over 6. All right. So in this case, again, this one is outside of the green region. So we do either move it over here to negative pi over 6. Well, actually, let me keep it red. Or move it over here to pi over 6. Which one is going to be the good one? Well, in this case, for negative 5 pi over 6, tangent is positive. Right? It's positive in this case. So in this case, this one is not going to be a good choice because here in this 4th quadrant, tangent is negative. So this is going to be the right choice. So we need to rewrite this as tangent inverse of tangent of pi over 6. And in this case, only then we're good to cancel this and get pi over 6 as our final answer. All right. Let's look at what the next page is. And well, in this case, we're good to go, and simply boom, 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 and boom, boom. And the reason why we can deliberately do this is because the range of the arctan or actually the range of the tangent function is all real numbers, as we saw in the previous page. All right, let's go back to verify that. Well, the composition in this direction, it goes negative infinity to positive infinity, any real number as opposed to sine and cosine. All right, so let's go back to find inverse function. So we're given a trigonometric function. Let's find its inverse. So number one, the procedure to find the inverse function is to change the f of x symbol to y, and then replace or interchange x's with y's. Alright, so and then solve for y. So subtract 2 to both sides to get 3 cosine of y equals x minus 2. And then divide both sides by negative 3 to get x minus 2 over negative 3. And then this negative will change the order of this function over here. So what are we going to do here is, well, do the cosine inverse on both sides. Alright, so these are going to cancel, and y equals to cosine inverse of 2 minus x over 3. Notice I'm changing the order and using this negative sign. And of course, in the end, what you want to do is to denote this as f inverse. We don't leave it as simply y. And that's final answer for this part of the function. Alright, let's state the range of f and the domain and range of f inverse. Well, we need to find the range of the function, of the original function. Well, so this is what I'm going to do. What I'm going to do is to have again y equals to negative 3 cosine of x plus 2. And then what I'm going to do is I'm going to solve for the trig function. So that's negative 3 cosine. Notice in this case, I'm not interchanging x's and y's. I'm just solving for cosine for a reason I will show you in a minute. That's going to be y minus 2 and then cosine of x equals to y minus 2 over negative 3, which is the same as saying 2 minus y over 3. Okay, well, how will this be useful? Well, keep in mind that the cosine function has a range of negative 1 and 1. And what I'm going to do in this case is cosine x equals this expression. I'm going to substitute this expression over here. Alright, instead of cosine, I'm going to have that to y minus 3. 2 minus y over 3. And solve this compound inequality. So I'm going to multiply both sides by 3 to get negative 3, 2 minus y less than 3. Right, that's what I did. Multiply the 3 on the 3 sides of the inequality. Right over here they cancel. And then subtract the 2 on the 3 sides of the inequality. So that's a negative 5 less than or equal negative y and 1. Alright, be careful here because we need to isolate the y. In order to do that, we need to divide the 3 sides by negative 1. But that in this case, what's going to do is reverse the inequality signs to 5 greater than or equal y greater than or equal negative 1. But in this case, this is not how we read inequality. We don't read it from larger to smaller. We need to reverse the order of the inequality to make it reach like -1 to 5. All right. Now, if you look at the graph of the function, I have a graph for you. Let's see. I had a 1. Okay, let me clear this. I have it here. What's the range? The range goes from -1 to 5. All right. So for f of x, the domain is 0 to pi, and the range is -1 to 5. And for f inverse, everything reverses. Keep in mind that everything reverses so the domain becomes the range of the original function, and the range becomes the domain of the original function. All right. Let's do another example, another very quick example. Y equals to 2 sine x minus 1. And interchange. So 2 sine of y equals x plus 1. So what we want is to solve for sine. So we can, in the end, and let's do the inverse sine on both sides. So cancel. Y equals inverse sine of x plus 1 over 2. Well, again, keep in mind that we change this to f inverse notation. All right, that's what we're looking for ultimately. All right, now we need to find we need to do all this again, but for this function. So y equals to 2 sine x minus 1. I'm going to solve for the sine function. So in this case, 2 sine of x equals y plus 1. And in this case, again, I'm not interchanging x's and y's because I'm not finding the inverse. I'm trying to find the range of the original function, which is going to be the domain of the inverse function. So sine x will be y plus 1 over 2. And then, well, keep in mind that sine has a range from -1 to 1. And we're going to do the same trick, which is to replace this with this y plus 1 with sine of x. Alright, so -1 less than or equal y plus 1 over 2 less than or equal 1. Multiply the three sides of this compound inequality by 2 to get a -2 less than or equal y plus 1 less than or equal to 2. And finally, add 1 to the three sides. Actually, subtract 1 to the three sides of the inequality. That's a -3. Y is greater than -3 and less than or equal to 1. In this case, we don't reverse, we don't flip anything the same way we did it over here, right? So the reason why I covered two examples is so you can see what to do in a situation like this, in which in the middle you get a negative, how you treat this, and then we're good to go. All right. So this is for f. Okay, let me use a different color to make a distinction. For f, the domain is it's given, it's -pi/2 to pi/2, and the range we just found it out, it's -3 to 1. And for f inverse of x, the domain And the range, they just get inverted, so that's a negative 3, the negative 3 to 1. And the range goes to negative pi over 2 to pi over 2. And that's final answer for this example. Alright, let's do one last page in which we are going to solve equations involving inverse trigonometric equation. And these are very, very short as opposed to the actual trigonometric equations that we will do in this chapter as well. So all we do is solve for the inverse trigonometric function. We'll divide both sides by 3 to get sine inverse of x equals to pi over 3. And then we do the inverse of this inverse sine, which is to take the sine on both sides. Alright, so that's going to, well, cancel. And that's going to give us x equals to sine of pi over 3. But what's sine of pi over 3 from the unit circle? We can get that sine equals square root of 3 over 2. Final answer. Let's do another one. Here, let's combine like terms. Tangent inverse minus 5 tangent inverse, that's a negative 4 tangent inverse of x. Minus pi over 3 equals to pi over 3. And then I'm going to add this pi over 3 to both sides. And in this case, well, 2 pi over 3 plus pi over 3, that's going to give me 3 pi over 3. Alright, and well, these 3's are going to get canceled. And let's solve for the inverse trig, which we do by dividing both sides by negative 4 tangent inverse of x equals negative pi over 4. Alright, and we are only one step to get that x by itself, which is take the tangent on both sides. Alright, so x equals to tangent of negative pi over 4. And well, negative pi over 4 is the same as saying 7 pi over 4. Alright, we're going down, we're going clockwise to 7 pi over 4. And tangent is defined by square root of 2, negative square root of 2 over square root of 2. That is y over x. And well, when we divide the same number with the opposite signs, all we get is simply negative 1. Alright, if you're, just in case you're curious, negative root of 2 over 2 divided by root of 2 over 2. And cancel, that's negative 1. And this is a good place to quit. I'll see you in the next video.